Very good afternoon to you all. So our today's so today we will today's our topic is introduction to Google Earth Engine. So in your previous lectures you have learned basics of JavaScript. Now with the help of those basic JavaScript we will learn today how do we access Google Earth Engine data. So in today's lecture, I will introduce you. So first, what is Google Earth Engine? Then how do we access or visualize or do some elementary processing on that Google Earth Engine data using JavaScript. So I will be explaining those these things. So now let's start with what is Earth Engine. So Earth Engine actually is much more than our traditional GIS systems. So Earth Engine is big data analysis and visualization platform. So it offers a lot of functionalities compared to our traditional GIS systems. So big data means big data in terms there is a huge there is a lot of data available at the Earth Engine. Plus it provides you a mechanism to access and process that huge amount of data in very less time. So these are the basic properties of Earth Engine. First thing, it is inherently parallel system. Actually, the Google Earth Engine is Google's is based on Google's cloud platform. So it's inherently parallel system. So your the data is spread across multiple machines on internet, and even when you access or process that data, so that processing doesn't happen on a single system. So it happens across multiple systems together, and the results are combined and is presented to the user as a single output. Plus, Google Earth Engine is basically designed for the scientists or people who are working in the area of remote sensing. So even if you don't have much exposure to any programming language, you can work on the Google Earth Engine very easily. But you need to know some basics of JavaScript or Python programming. So then you can work. So it is not designed for software engineers. It is not designed for software engineers. It is designed for common users or scientists who doesn't have a sound programming background. Plus, what is the goal? Why it has been developed? So it has been divided. It is designed to make it easy for non-traditional users. So people who are not it means it is designed basically for the people who are new to remote sensing area. Even they can work on the remote sensing data quite easily. So it is designed such a way that even people who don't have quite good experience in remote sensing, even they can work on the remote sensing data quite easily. This was the basic idea behind the Google Earth Engine. It is focused on the society's biggest challenges. So like there is a lot of data available, but getting information or knowledge out of that data is quite difficult. Suppose if you don't have very if you assume that you are not computationally rich, means you don't have quite a large number of resources to process that data, because there is a lot of data available, but for processing that data you need a lot of resources as well. So suppose if you are so with you so for using Google Earth Engine you don't need you don't need a lot of resources. You can just access all the resources available at Google's cloud at free of cost. So Google is offering those things free of cost. So for that, so that there is a lot of data available, and by processing that data, we in a hope that we will be able to devise some solutions for, like maybe like if you are working on a forest area, so then by analyzing 10 years or 20 years of data continuously, so you can like you can track in which all the areas deforestation is taking place, or like you can monitor droughts, or even you may be able to, like if you are able to predict, even you may be able to predict droughts, like some disasters, sustainability, or you can track climate changes and what is the impact of those climate changes. Even you can work on global food security, like you can track how the crops are grown, how, and if there is some problem with the crops you can track, and so on. So with the help of this huge amount of remote sensing data, we may be able to solve the problems of the society. So this is the basic idea behind Earth Engine. Now this is now about the Google Earth Engine. So Google Earth Engine has almost maybe more than 40 petabyte Google Earth Engine more than 40 petabytes of public data catalog. So its catalog includes imagery plus some geophysical data as well. So imagery of Landsat starting from Landsat 4 to 8 or Landsat 7, that is resolution of 30 meters. So all Landsat data is available on the Google Earth Engine freely, so you can access it quite easily. Like then MODIS data also is available from year 2000 onwards. Similar way, Sentinel-1 SAR data also is available. Sentinel-2 Sentinel-2 data plus some geophysical data like digital elevation models, land cover, surface temperature data. So lot of data is available. So almost more than 40 terabytes of data is available. So now, so you need to, so you have any problem or you need any data, so you can access Google, the data on Google Earth Engine. Plus, Google Earth Engine can be used for weather forecast or climate or developing climate models. Plus, it has more than 300 analysis ready data sets available for you. So there is the data is available, everything all pre-processing, everything is done on the data, and you have to just access it. Plus, now it has more than 30 years of satellite images are available to you. So with that, you can process any data and derive any results. Now next question comes, how do you use Google Earth Engine? So for using Google Earth Engine, first thing you need a Google account. So once you have a Google account, then you need to go to the signup.earthengine.google.com. So first of all, you need a Google account, then you need to sign up for Google Earth Engine. So first thing, then you need to send a request to the Google. So now they will review your request, and based on the review, so you will be granted access to the Google Earth Engine. So it's quite simple process. So once you apply, within 1 or 2 days, they generally approve your request, and then you can start using Google Earth Engine. So for accessing the data or functionality available in the Google Earth Engine, they have provided APIs or application programming interface in 2 languages mainly. One is you can use JavaScript, or you can use Python. So in today's lecture, I will be covering the JavaScript APIs. So for developing JavaScript APIs, you need not have separate editor or something. So Google Earth Engine itself provides a code editor for writing code in JavaScript. So it is based on Node.js. Plus another is Python APIs are also available if you are into the data science and you have experience in programming languages or Python specifically. Then you can use Python APIs also. The advantage of Python APIs is that now you have the big ecosystem of Python data science available at your disposal. So now you can use you can take data from Google Earth Engine and analyze this using different Python libraries. So Python, there is a module called EE in Python. Then you need to import, and then you can use Jupyter Notebook or Google Colab for accessing the Python using Google Earth Engine using Python APIs. So once your account is activated, so this is the basic structure of a Google Google Earth Engine code editor. So anyway, I will be showing the practical demonstration as well. So in Google Earth Engine, this is the main area where you write your code. Plus this is the area, this is the search area. There, like, you can search the different Google data catalogs like Sentinel data. So Sentinel data is cataloged in a separate way. Then Landsat data also is cataloged similar way. So this is the area, search area, where you can search for different data sets or places. Anyway, I will be showing it. Then here it is script manager. This is what they call script manager. Here you will be saving your scripts. Then there is docs for API documentation. Like for all APIs, all help is available in the docs tab. So you can access that also using here. Then this area is the results area or console. So whatever output of your script, whatever you are printing on the console will be shown here. Then on the bottom, you will see the map. So in the map, you can add images for visualization and other things. So now let's start with the basics of geospatial data. So what is geospatial data? So geospatial data is any data when you combine location information with your attribute. Whenever you combine location information with the attributes, whatever you have collected, that is called geospatial data. So geospatial data means geospatial data combines location information with the data available. So information that describes objects, events, or other features with a location on or near the surface of the earth is called geospatial data. So even in geospatial data, you can combine temporal information also, like you may be analyzing the temperature of some particular area for all 20 years or 30 years. So similar way, so into geospatial data, first of all, you are combining location information with your data, and it can be temporal as well. So whenever you are analyzing a time series, so it can be temporal data as well. So types of geospatial data. Basically, if we divide geospatial data, basically we divide geospatial data into two categories. One is called vector data and another is called raster data. So vector data means any data that has clear, distinct boundaries. So that any data which has clear, distinct boundaries can be represented as vector data. Say for so vector data generally is represented using point, line, or polygon. So point, for example, if you see whenever you are seeing a map, so in map you see the boundaries of a country. So boundaries of country are represented using polygons. So vector data generally is represented using line, point, line, or polygon. So for example, point. So point you can represent as a city using a point. So whenever you are at very low scale, so then you can when you are seeing entire world together, so then every city you can represent as a point. But when you increase your zoom level, so then you may be representing city using a polygon. So like point, so you can represent a city or anything like a point, or you can represent vector data using line. So maybe like you are representing a road or a course of a river can be represented as a line, or you may be representing your data as a polygon, showing the maybe like showing the outlines of boundaries of a country or outlines of a coastline, cities, and so on. So vector data can be represented either using point, line, or polygon. So like here you are seeing the map of India. It is showing the outer boundaries of India or the boundaries of state using polygons. So next comes the raster data. So a raster is an image with matrix of values representing the values of some observed attribute. So that observed attribute may be the surface reflectance or temperature of some area. So like here you are seeing in this so this is this image, this is a temperature of entire earth over some particular day. So this is represented as an image, or even that like ultimately it will be a matrix, a two-dimensional matrix. Here you can see that this is the matrix showing the temperature at different points. Plus this can be like a raster image can be a single band image, or it can be multi-band image. So multi-band image, every band can represent some temporal information. So like you can say that this was the temperature of this area at 10 o'clock in the morning, then 11 o'clock, then 12 o'clock. Or it can be a multi-band image, like one band is red, green, or blue, and so on. Or it can be, the bands can represent either temporal or different EM wavelengths. So now this was the basics of Earth engine and this was basic theory of about geospatial data. Now let us see that how do we do it in Google code editor. So for starting, as I explained, so first thing you need to sign up to the Google Earth Engine. So once your request is approved, then you need to go to the code.earthengine.google.com. So once this is done, then you will see a So this is the code editor which I showed in my slide. So this is the code area where you will write your script manager or script. So in the script area, whenever you can create, or some already existing examples are available by default. So this is the script area, and this is the area where you can search for new catalogs or new places, so that you can directly move to the map. This is the area where you can search for the data sets, and this is the console. This is the console where you can see the output of your script, like if you are printing something and so on. So this is for seeing the output of your script. Then in the console only there is a thing called inspector. So inspector can be handy for, suppose if you find that there is some problem in your script, so inspector will help you in debugging your script. So I will explain it with the code and how do you use this inspector. Then next thing is the map. So in the map you can add new images and so on with this help of script. Just I will demonstrate you how to use it. And once your script is there, then you can click on the run button to run your script. And even suppose if you want to share your script with some of your friends, then you can generate the link to your script, and that link you can share with your friends so that they also can access your script. Plus this is the docs tab. So docs tab shows the help on different functions available in Google Earth Engine. So just you can, if you want to know about any function available in Google Earth Engine, like suppose if I want to know about more about ee.image, so which all functions are available on e-image, I can search here. So this is the documentation of the API. So like if I call I want to see the documentation, what does this e.image.cat function does. So I can explore it, I can just click on here. So then I can read about the e.image.cat function. So this way you can explore the documentation also is available directly on you need not search on the Google, directly it is available on the code editor itself. So now let us start writing a small hello world script. So anyway you are coming now, I assume that all of you done the lecture on basics of JavaScript. So anyway I will be covering, for just sake of completion, I will be covering once again the basics. So in JavaScript, so here I have already written some code, and I will keep on explaining and running the code one by one. So now suppose, so in any programming language, the first thing generally what we do whenever you run a program, we just run a hello world. So hello world is just an introduction to any of the programming language. So in JavaScript, if you write, so suppose if you want to comment something, so that you need to write under double slashes, or you can use multi-line. So suppose if you want to print hello world, in JavaScript. So suppose here you can see that all other lines in my script I have commented out. Only one thing is so here suppose if you want to run print something on your console in JavaScript. So first thing what you need to do, you can just print and hello world. Now once your script is ready, suppose if you want to run it, so you just need to click on the run button. And you can serve the output in the console. So if you see in the console, it has printed hello world. So this is the hello world in JavaScript. Now, this is the now I'll cover the basic JavaScript data types. So JavaScript has these basic data types, suppose strings, numbers, lists, and objects. So these are the basic data structures which are available in JavaScript. Now suppose if you want to define a string in JavaScript, so you need to define it using var. So var means variable, the name of your variable. So suppose var green string equal to, then you have to put your characters inside single quote. So here I am defining green string that contains hey I am green. So these I am green you need to put inside single single quote, and the line should terminate with a semicolon. So suppose now if you want to print what the green string is there, so then you can just use the statement print green string. So print green string will print the green string variable. Similar way, suppose if you want to use a numeral like integer, float, integer or floating point number. So just similar way you can define the name of var and name of your variable var number equal to, then you can assign it a value, a numeral value like 42, 42.0 or 43 and so on, equal to 42. Then you can say print, then suppose if you want to print it, print answer is number or something like. Then there is another variable called list. So whenever you want to store multiple values together, so there is an other data type called list. So list you need to, suppose how do you define a list? For defining a list you need to put inside square brackets. So suppose if you want to, I am defining a list of numbers is equal to inside square brackets 0, 1, 2, 3, 4, 5 or 3 and 5. And suppose if you want to print list of numbers. Similar way you can define a list of strings. So this is this list of numbers, list of strings. So list of strings, then A, B, C, D inside single parenthesis. Then there is another thing called like object. Suppose if you want to define an object in JavaScript, so object must be encompassed in curly braces like dictionary in Python. So here I am defining a variable like I am defining here a variable called object. So object is not a string, list or numeral, it is a dictionary kind of thing. So object has multiple elements in it. So object has like foo variable, a foo variable that has the value bar, then a variable bars that has the value 3, and it has another list inside it that is called stuff. So previously you have seen that we have defined three variables different, like we defined a string, a numeral and a list. Now we are compacting all these all together inside a object. So here we have defined a variable object that contains a string, a numeral and a list of strings. So once the object is created, now suppose if you want to access any individual element of that object, so if you just print object, so it will print all the objects. Now suppose if you want to access the value of foo variable inside my object, so that you can access it using object and inside name of the your object, and inside square brackets name of your object in single quotes, or even you can call like object dot. When I will show you the example. In similar way, you can call with object dot also. This I think you have studied in. You must have studied in your JavaScript lecture as well. Next thing is comes how do we write functions in JavaScript. So function is a reuse function are another way to improve the code readability and reusability by grouping a set of operations. Suppose you are doing some set of operations repeatedly over multiple data. So instead of writing those steps all together in different places, what you can do, you can combine all those steps together in a function and you can just call that function. So how do we define a function in JavaScript? For defining a function is similar to defining a variable, but there is slightly difference. So the function name should start with where. So where, and first thing is the name of your function. So like suppose I'm going to write a function name function called hello function. So I've defined here where hello function, then equal to function, then parameters you need to pass to your function parameter 1, 2, 3. Then inside the curly braces you need to write the body of or whatever steps you are going to execute inside your function, like all the statements. Then finally a return statement. So return will return the result of your function. So for example, here I have written a function called reflect. So reflect is just taking an element as an parameter and it just is returning that function. So here I have defined a function variable reflect equal to function element, return element, and it is returning, and the element similarly is not doing anything. Now suppose you want to call this function now. So how do we call the function? So just defining a function doesn't do anything at all. So for using the function you need, after defining you need to call the function. So here this statement is calling the function where ref equal to reflect. So how do we call a function? Function name, then parenthesis. So inside parenthesis you need to pass the arguments to the function. Here this particular function is taking a single argument. We are passing a single string and it returns same value. This is string. So let's see with code. Then we will come to the next Earth Engine objects. So after this print hello world, now let us see that how do we use strings and all. So first I will delete this portion. So in the block 2 I have done the code for this. So same thing whatever I have shown in the slide. So here you can see that I have defined a variable called green string. So suppose if you want to define a string variable, so where name of your variable and the value you want to assign to that variable. So here I am green. So suppose if I run this particular statement print green string, so it will print on the console, hey there I am green. So similar way, suppose if you want to define a variable of number that contains numeric value, so you can define where number equal to, so we can assign it value whatever you wish to assign it. You can print it the similar way. Now this is the way list of numbers. So list of numbers is a list of integers. So list of numbers contains values 0, 1, 2, 3, 4, and 5. If you want to print 1, 2, 3, 4, 5. Then similar with this list of strings is a list which contains strings. Now let us run this code and see the output. Then we will talk about object. If I run this code, just I need to click on the run. Then here you can see the outputs. So first thing it has printed, hey there I am green. This is the first string we printed. Then the answer is 42. This was the second statement. then list of numbers it has printed, and list of strings. Similar way, let us see that how do we define object. So these are individual variables. Now we are combining these all variables into a single variable. So what is the purpose of object? Like suppose if you want to store some data of a student. So student will have name, age, or maybe class, date of birth, in which subject he is enrolled, and so on. So instead of storing these all in different variables, what we can do, we can combine all this information together and store in a single variable, maybe called student. So student's name, age, and so on. So similar way we have defined here a variable called object. So here we have defined a variable called object. So this has three elements in it. One is foo is a string, then baz is a number, then stuff is a list of strings. So once we have defined an object, or you can say student, now once it is done, now suppose if you want to access individual element of this object, so that you can do using object, name of your object, like here the name of object is also object. Instead of that, if I say student, so just I print student. Student. So instead of this, I call it the name of student. His standard, or in which standard he is studying, or I'll say these are the subjects students are enrolled for. Now suppose if you want to access student, for this particular student, what is his name? So student in square brackets, either you can put it name, student name, or you can call, like here you have called student dot name. So student dot subjects. Now suppose if I run it, here it was student. So I have made a mistake here, student. Now if I run it, now here you can see that the thing is printed first. Student is printed as an object or dictionary, his name, standard, and subject. So all the variables of the student gets printed. Now suppose instead of printing all the variables, you want to access an individual element of your object. Like here, I'm just accessing the name of the student, bar. So here we have assigned in name bar, and similar way we have accessed the subjects of the student. So this way, object, then object name, then inside square brackets you can put inside single parenthesis, single inverted commas, you can say the name of object or object dot. So either you can use a dot notation, or you can use square brackets for accessing individual element of the object. So next thing is like how do we define function? So as shown in the slide, right? So this is the way how do we define a function. So I will cut this. So here I am defining a function where hello function equal to function, then parameters, then return statement. This is done. So here we have defined a function called where reflect equal to function. It is taking a single argument called element, and it is just returning the element which we are passing to it. Return element. Then suppose if on this statement, I am just calling this function reflect, and I'm passing it an argument good to you argument. So suppose if I run it, prints good to you. So similar same function. So suppose if you don't want to use, you can just directly define like this also. Function so you can say function, then you can write name of your function reflect and take an argument a, and inside this you can say print hello. So this way also you can define a function reflect underscore a, I will call underscore 1, and you can call it underscore 1 as a. So it's just printing hello. Either you can define like it using a variable like where reflect equal to function, or directly function, and you can call the function. Now, next important thing when you do Google Earth Engine programming is the difference between client versus server. So we'll cover Earth Engine objects. So Earth Engine, there are two types of object in your Earth Engine JavaScript. One is called client object, or another is the server object. So JavaScript objects or primitives that exist in your code or browser are the client objects. So objects which are objects in your script which are local to your browser, like you are defining any single variable for any UI element or a variable that is your browser, that will exist on your browser only, that is called a local variable. And there are other type of variables or objects that will be residing on the Google Earth server. So objects which are residing in, so you need to make a distinction between the objects which are residing in your local browser or your local system, and objects which are residing in the Google's Google Earth server. So objects which are residing at your local browser are called client objects, and objects which are residing at Google server is called a server object. So actually what happens, for every server object that is residing in Google's Earth Engine, there will be a proxy object in your script. So you will be able to access that object residing in the Google Earth Engine using that proxy object. So in your script, anything that is starting with EE, so suppose you say EE.string, so that is, you can identify it as a object that is residing at server. And others are your simple client objects. So actually the proxy objects doesn't contain anything. So proxy objects are just a handle for the objects which are residing at Google server. So Google Earth Engine will just use those proxy objects for communication between your local object and the server. So let us see how do we define or differentiate between server objects and client objects in your script. So here you can see that first I am defining a single variable called client string. So client string, I am assigning it a value I am string. So this client string is an object that is residing or existing at my local browser. So if I want to inspect the type of it, so if I just script print type of this client string, if I run this string, this if I run just this code, it will print me like type of client string is equal to string. So string means it is a print type string. So this it means it is a client object. Now similar way, instead of that, now I am defining a variable here called variable server string. Server string is equal to, now I have defined it using EE dot string. So EE means this particular object is not existing at the local browser. This particular object is existing at the server end. So suppose now you have some data at your client end and you want to send that data to the Google Earth Engine for processing. So for doing that, you need to pack your data in a EE dot container. So like suppose if you have a string data existing at your client side and you want to send it to the server for processing, then you cannot directly send it to the server directly. So you need to wrap your data inside a string container of EE and then it can be sent to the server. So here like you can see that this EE dot string. So I have a server string that I want to send it to the Google server for processing. So then I have to encompass it into EE dot string object. So here EE dot string and I am not a string. You can say now if I print it, the same thing, print type of this server string. If I do, it prints as an object. So this is not, here you can see this printed as, it will print as a string, but it will say this is an object. So prints anything that is starting with EE dot is a Earth Engine object. So that object is residing or existing at the Google server. So now suppose if you want to print information about that object, then you can call getInfo function on that object. So server string, suppose the object which is residing at server end, suppose if you want to process it in your script, then you can call getInfo function on that. So now suppose if you want to define this, you want to define client side objects and send it to the server. So similar thing you can do, like suppose you here variable a string. So I have defined a variable called a string. Now suppose if you want to send it to Google server for processing. So then what I need to do, I need to wrap this in another e dot string container. So variable e string, I've just called it called e.string. Now this e string variable will be sent to the Google Earth Engine for processing. But a string, this variable is my local variable and this e string is my server variable. Similar way, suppose if you have some number or numeral value. So then same thing, you can like define first it as local, or like even you can do it directly. In the previous step, we have defined first a string and then to the e.string container we have passed the value of a string. But the same thing you can do in a single statement as well. So like server number e.number, directly instead of passing a separate variable, you can directly pass the value also to it. Similar way, suppose if you have a list to be sent to the Google Earth Engine for processing, then you can pass your list in a ee.list container. So ee.list and the list or list of your elements. So suppose instead of that you have a sequence. So sequence also can, like you want to send numbers 1 to 5. So instead of sending at separate numbers, you can call a function ee.list.sequence and just you can pass it on. Similar way, you suppose if you have dates. So for date there is a container called ee.date. So ee.date will create container for date. Now these are the, I will show it with the example as well. So now first see what are the basic data structures available in Google Earth. So any raster data is represented as an image in Google Earth Engine. So images are composed of bands and a dictionary of properties. So actually properties means, suppose there is properties will contain the metadata associated with your image, like when this image was acquired, what are the conversion factors for different radiance values, which are all bands. So any raster image is represented using an image data structure. Image will contain different bands plus some properties. So properties may be like when the image was acquired, when the image was processed, when generated, and other metadata associated with the image. Next is feature. Any vector data is represented as a feature in Google Earth Engine. So features are composed of a geometry, because geometry will be like point, polygon, or line. So every feature is represented as a geometry plus the attributes associated with the geometry. So for example, if you are storing a city, so city will have a geometry like point, or its latitude and longitude, plus maybe, for example, name of the city. So image collection is a stack of images. An individual image is represented as an image and a collection of images. Like all images acquired by the Landsat over the 20 years. So that will be represented using a image collection. So image collection means all the images of that particular group. So Landsat 8's all the images will be represented using an image collection. So similarly, there is a collection or group of features combined together is a feature collection. So let us see directly now to the code. So the same thing what I have shown. So this is just I'm first defining a client side object called client string. Then if I just print type of client string, it prints it says this is a string. When I print a type server string, then it prints an object. So this server string is not a client side object. So server string is a server object. So this way you visualize the output of these things. So this is what, suppose now you have a string and suppose you have a local, so you have stored some data in your local server, and suppose or browser, now you want to send it to the Google Earth Engine server for doing some kind of processing. So so as I explained you, so this client objects will exist on your browser only, but you want the processing to be done at the server end. So for that, what you need to do, you need to wrap your data inside a EE container. So suppose if you want to send a string for processing at the server, so then you need to wrap it into a EE.string container. Or suppose if you want to send a number, then you need to wrap it into a EE.number container. So now if I run it, okay, you will, anyway, right now you might not be appreciating what it is, but as you see later in the examples, you will be able to better appreciate it. So these are server objects and client objects. Now this is the basics of JavaScript. Now using this JavaScript. Now, till now, we have not accessed any data from the Google Earth Engine. Now we will access the data from the Google Earth Engine. Now, as I explained, any raster data is now, as I explained, as I explained to you, any raster data is represented as an image in Google Earth Engine. Now, suppose if you want to display an image in Google Earth Engine or access an image in Google Earth Engine. So, actually, Google Earth Engine has stored a lot of images. So, every image has been given an image ID. Similarly, every image collection has been given an image collection ID. So, for adding an image to the map, so first you need to. So anyway, first this is the name of my image. Anyway, I will explain you how do you search for this name of image, because you don't know the image right now. So as of now, you assume that there exists an image with this name on the Google Earth Engine by default. And how do we will see that? How do we access this particular image? Now let us see first this. Now suppose I have defined a variable called variable Gangotri. This is the image of Gangotri area. ee.image. The ee.image constructor takes the name of the image as an argument. So I have passed the name of the image. Later on I will show you how to search for that image name. So Gangotri is equal to ee.image. Now suppose if I want to inspect this particular image, I want to see the metadata of this particular image, I can just print Gangotri. So if I run this code, you see that in your console right here, you will be seeing the date of this image. You can see that this type is image, ID of this image is Copernicus S2. This is Sentinel image. And this is the band information of this image. This particular image contains these all bands B1, B2, B3, B4, B5, B6, and so on. And these are other properties of the image like cloud pixel percentage, how much pixel percentage is how much cloud cover is there in this particular image, like data strip ID, other details of this particular image. You can see so easily. Now let us visualize this image. We have retrieved the basic information about this image. Now let us see how do we visualize this image. So for visualizing an image, we need a map object. So every image will be displayed on a map. So for adding an image to the map, you need to call a function called map.addLayer. So map to this function map.addLayer will add this particular image, Gangotri image, to your map. And actually, once this is done, now what we want to do, we want to map center object of this image of this particular map. We want this particular image. So whenever we open the image, we want that directly your browser should point to that area in this, because that image. So for that, you need to call map.center object. So center object of this map will be this particular image, and this is the zoom level. At particular zoom level, like if your zoom level is very high, you will see the more detailed image. When your zoom level is low, you will see the more area but less resolution. So first you need to create a variable call using ee.image and pass it the name of your image as an argument, and then map.addLayer to add this image to your map. Now suppose if I run this image, now suppose if I run it, now if I run this image, now you can see that Now if I run this code, if you can see that there is something like this is, instead of showing an image, it is showing just some black spot in the map in some area. So though the image has been centered around this, now you can see that you are not able to see anything as of now. Is you are seeing something like some black portion. So why it is showing as black? Because we have not set the visualization parameters for this particular image. So actually this is a multi-band image and it has certain values for reflectance value in each band. Now we have not set the visualization parameters for this image, like which all bands we want to visualize, what is the range of the number that you want to visualize. So that things has not been done. Now let us see how do we do it. Now here you can see that same thing I have same variable Gangotri and map dot center object. I have centered the map around Gangotri image, and I am defining a variable called visualization. So visualization here is an object. In the visualization variable, I am defining the minimum value, maximum value, and which all bands I want to visualize. So here just I want, because this is a sentinel image, sentinel's band 4 is red, 3 is green and 2 is blue. So just I want to visualize a red color or true color composite of my image. So for that I have defined the visualization parameter like minimum, maximum, and which all bands I want to visualize. So band 4 will be visualized as red, 3 as green and 2 as blue. Then same thing I am calling the function map but add layer. In add layer I am passing the argument variable name and visualization. So in the previous add layer I have not called the pass the visualization parameter, and next is I am passing it the name of this particular layer as Gangotri. Now suppose if I run this code, now here you can see that instead of showing a black spot, satellite image of this particular area. So this is the sentinel image, some some part of Uttarakhand. So this way you can visualize any image in a Google Earth Engine. Now the question was like, how do we know that what is the ID of this particular image? So the ID of particular image you can search either directly like here. So in the search places, here you can search, like suppose if you want to search for sentinel images. So you can just type here sentinel. So then here it shows the details of this catalog. Now suppose if you want to visualize the Sentinel-2 multi MSI's L2A data or any other. So here it is listing of Sentinel, Sentinel-1, Sentinel-2, Sentinel-3. Like suppose if I am interested in Sentinel-2, so I can just click on this and documentation about this image collection. So you can read about this image here. And here you can see that it is given collection snippet, image collection. This is So this is image collection ID. Similarly, if your data is represented as single image, it will be a e.image. So, but here it is the image collection, like all Sentinel-2 images, surface reflectance images. So that is in Copernicus S2SR. This is image collection. So from here you can search the image ID or image collection ID for this. So directly from the search area, or suppose instead of this you can use on the Google itself. You can search for Google Earth Engine data sets. So directly you can go to the Google Earth Engine data catalog. So like here, suppose if you are interested in weather data or you are interested in Sentinel image collection, so you can just click on Sentinel Landsat or any other image. Then from here also you can get the, like suppose if you are interested in SAR data, click on these or SAR data from Sentinel series is available here. You can just click on here. And it will show a detail. So here Earth Engine code snippet it shows. So E collection, this is the ID of this particular image collection. So from here, either from here also you can search the ID of your image or image collection or feature collection, whatever is available in the Google Earth Engine. So this is, we have visualized a true color composite. So instead of, suppose if you want to visualize the standard false color composite, so in red, suppose if you want to display that NIR, change the band to band 8, 4 and 3. Now instead of true color composite, now you can see the standard false color composite of your image. Similarly, you can visualize any other bands. Now there is a thing called in this Google Earth Engine, there is an inspector. Now suppose if you want to inspect values of some particular area or some particular pixel, so for that what you can do, you can just click on inspector. And suppose if you want to more detail about these pixels, so just you can click on this. Then you will see here in your inspector, it shows the detail about that pixel wherever you have clicked. Inspector pixel, you can see this is not visible in my screen. So it shows the details of the image plus the values or reflectance values in all bands together. So this way you can see the spectral signature of that particular pixel. So you can click on any pixel. So you know the from this you can know its lat long. Pixel is not an identified pixel box, and spectral signature of that pixel very easily. So like here you can see that these are the this is the reflectance value in band 1 through band 4, and this way you can visualize the spectral signature of pixel very easily using inspector. So with inspector you can inspect in more detail about your image. So this way we can visualize our image. Now suppose so this was we have visualized an image. Now let us see how do we visualize an image collection. So as I explained, image collection is a stack of images. So you can so all different so images of Landsat 8 are all the images which Landsat 8 satellite has acquired has been stacked together, and that group of those images has been given a name. So that all the images have been combined into a single collection, and that collection has been given a name, like you can say that Copernic Sentinel-2 images has been combined in an image collection called collection Copernicus /S2. Similarly, all different images has been combined to an image collection. So image collection, like if you take an example, Landsat. So Landsat 8 will have some 10 or 30, 20 years of data. So all images will be the image collection. But when you want to analyze or visualize the image, you will not be interested in the entire image collection. You will be interested in some particular dates image or some particular areas image. So either you have to filter the image for processing, because if you process or visualize all the images together, you will not be able to get anything. So what you need to either temporally filter your images or spatially filter your image for processing. Image collection, sorry, for image collection, so that you get least number of images or images of your interest only. You need not process all the images altogether. So for that, Google Earth Engine provides you different kinds of filters. So you can filter your images either spatially, temporally, or based on some metadata as well. So there are a lot of filters available in Google Earth Engine, so that you can reduce your reduce means you can narrow down your search. So now suppose I will show you now how do we do some basic filtering on the image or on image collection. Now here, now suppose if I am interested in, I want to first spatially filter an image collection. So I want Sentinel's images which are acquired over IIRS Dehradun. So for knowing the location of Dehradun on the map, you can search first Dehradun. Like here I have done. If I search here Dehradun, so it shows Dehradun, Uttarakhand. So it takes me to the Dehradun. So this is and then I have to identify my location. Then if I click on okay, this, so this gives me the latitude and longitude of that point. So suppose now I am interested, I know that the latitude and longitude of my area of interest or my point of interest are these. This is the longitude, and second one is the latitude. So now I want to filter the images which are overlapping which are covering this particular point. Then later on, suppose if I want images from this date to this date only. I want images of this area only. So let us see how to filter the image collection. So for doing that, first I have to call the ee.image collection. ee.image collection. There we need to put the name of our image collection. So for Copernicus, all the Copernicus images, Sentinel images are stored in the collection Copernicus /S2. So we have created a image called image collection, ee.image collection /S2. Now suppose if you want to filter it spatially, like from this collection, only extract the images which overlap or which cover this particular point. So for that there is a function called filter bounds. So image collection dot filter bounds. Image collection dot filter bounds, then you need to pass it a geometry. Like you can see, pass it polygon, like if you are interested in some area. I am here now, I am interested in this point. Whenever, whichever images, all the images of Sentinel-2 which cover this particular point. So filter bounds and pass it an argument IIRS. IIRS is a geometry. Then suppose if I am interested in from this date to this date only, then there is another filter called dot filter date. So filter date will filter start and finish date. So all the images which were acquired during this time period only. So with filter date function. Now suppose this is done now, even there also there will be a lot of images. So in this satellite must have passed multiple days. Now in that also in that collection, again you want to filter, like sort that collection using cloud cover. So you want the image with least cloud cover be the at the top of your image collection, so that you can sort. There is a function called for sorting that sort. Now by which property you want to sort your image collection. So I want to sort my image collection using cloud cover. Sort dot cloud cover. Then second argument true. True will tell whether ascending or descending. So here we have accessed the image collection, Sentinel-2 image collection. Then we have filtered it spatially, then temporally. Then we have sorted the image collection. Cloud cover. Now suppose the image that again will have multiple images. Now suppose if you want to inspect first image from that image collection, so that can be accessed using image collection dot first. Image collection dot first function will fetch us the first image from that image collection. So suppose if you want to see that image, you can just call this. Let us see in more detail. So if I run, so on the console you can see. So she is showing the details of this particular image. These are the bands, and this is the image acquired on this particular date. You can visualize it more. Now let us see that how this image looks. So for viewing the image, same thing, we need to add this image to our map. So using map.addLayer function. What has happened? This visualization I have deleted. So what happened? I have deleted the visualization variable. So I'll just create it once again. So this way we can, especially temporarily, now our image collection will have multiple images. So from that, instead of processing all the images together, what we have done, we have narrowed down our images. So we have filtered our image collection so that we get only the images of our interest only. So you can filter the image collection temporally, spatially, or there are multiple, depending on some particular metadata also you can filter your image. Now let us see an example of feature. This is all about raster data. Now let us see how do we add some vector data also to our image. Now similarly, now suppose if you want to do processing on your image. Now for example, now suppose if you want to calculate NDVI for your image using Google Earth Engine, now that also can be done very easily. Now here again we have defined the start date and end date for our image. The same way image collection I am filtering first spatially then temporally. Then suppose if you want to, I am on the first image, suppose whatever least cloud image with least cloud cover, suppose if I want to calculate the NDVI for that particular image. Suppose if I want to do, so for what I can do, we can write a function called get NDVI. So here I have written a function called get NDVI. So I have defined a function get NDVI. So get NDVI is taking an image as an argument. So for e.image there is a function called normalized difference. So normalized difference will calculate the normalized difference of the two bands of that particular image. So we know that NDVI is NIR minus red divided by NIR plus red. So band 8 of the Sentinel is NIR and band 4 is red. So suppose if you want to call this, so we can just call image dot normalized difference B8 dot, then we can pass for which bands we want to calculate the normalized difference. It will return us a normalized difference image. So same thing here, we have defined filter collection and image collection and filtered the image collection. Now this is instead of on the color palette, we have instead, because this will NDVI will be a single band image. So we have defined a color palette for every these values, images will be represented in these different color values. So same thing, I am extracting the first image from the image collection. So filtered collection dot first. Then I am just calling the get NDVI function. Get NDVI function, I am passing this first image. Then for visualization, same thing like map dot add layer. First we are visualizing first, then NDVI image. Now let us run it. Here we can see that we have added we have calculated the NDVI and that NDVI image is added to our map. So now suppose similarly you can add like multiple layers also to, suppose with NDVI you want to display actual image also. Again, visualization is missing also anyway. So just with calling map dot add layer, you can add other layer also, where you can add multiple layers and the name of the layer. So this was about a raster data. Similar way, you can add vector data also to your map. So now suppose if you want to define, you can define a point, polygon or anything. Suppose if you want to add a point to the map, so you can define a variable point e dot geometry dot point, then latitude and longitude. Similar way, you can define a polygon. Polygon will be a series of vertices. So that way you can define polygon like variable polygon equal to, now suppose if you want to create a feature, as I explained, feature will contain geometry plus attributes. So geometry will be a single geometry, like here you can see the point is a single geometry. Similarly, you can define feature also. Feature will contain geometry plus, now suppose this area you want to give some name also. So you are attaching the properties area to the image, area and some system index, that is like index of every image. Now suppose if you want to visualize that. So for visualizing, same thing we need to call, like there we are calling map dot center object. So this will point will be the center object of our image. And suppose if you want to add a point layer, so you will call the function map dot add layer. There we are passing the image or image collection. Now similarly we can pass feature or feature collection. Map dot add layer point, then visualization parameter you need to just pass and name of that layer. Similar way, suppose if you want to display a polygon, so map dot add layer, the name of your feature collection or feature. Then suppose if you want to fill the color of that, for like similar way, edge color, fill color, some multiple other parameters are also there, you can read in documentation. And suppose if you want to fill the polygon with some particular color, then you can pass in color also. So now if I run it, now here you can see that and a polygon got added to the map. So this way you can add using map dot add layer, you can add any raster or vector data to your map. So that's all for today. Thank you very much.